Even the most average bystander would know of black holes. However, the knowledge of their existence and overall formation is not as commonly known. In the following presentation, I will inform you of this phenomenon that occurs frequently throughout the vastness of space. Before this presentation continues and the formation of black holes is explained, there is some important information that you need to know. Isaac Newton's first law, law of inertia, applies to black holes because since a black hole is so dense and has so much mass, it can bend light away from its straight path, the black hole being the unbalanced force. The third law is for every action there is an equal and opposite reaction. This means that if you act upon an object, you will feel the exact same force you applied. An example of the third law, according to the article titled Interaction Force Pairs, a bird flies by the use of its wings. The wings of a bird push the air downwards. Since forces result from mutual interactions, the air must also be pushing the bird upwards. The size of the force on the air equals the size of the force on the bird. The direction of the force on the air is opposite the direction of the force on the bird. So with black holes, the balance between the star's gravity and energy is equal, but if the energy gives out, the gravity will force the star's core to condense, because there's no other force to equal the gravity. When a star is reaching the end of its life cycle, there are options as to what happens. If a star has a certain mass, at least 3 times the mass of our Sun, it has the possibility of becoming a black hole. If a smaller star is dying, the process it will go through will be the top path because that star does not contain enough mass to be a black hole. Our Sun, for example, is a medium-sized star and will burn steadily for billions of years. But after the fusion from the core ends, the equal balance between the gravity's pressure and the core's energy is disrupted, and the star implodes. Then, the Sun will get hotter due to the outer layers forcing the inner layers to condense, and after, the Sun will grow into a red giant, swallowing nearby planets. Once it converts into a red giant, it burns off its outer layers as the red giant runs out of fuel. Next, a nebula begins and provides a show for all of the galaxy. Soon after, a white dwarf is born and will eventually, over time, become a black dwarf. But as for different stars with bigger masses, at the end of a big star's life, when it runs out of fuel from the core, it turns into a black hole after a progression of multiple stages. As normal, the star's gravity continuously pushes inward, keeping the star together, while the star's energy pushes outward from the core. But soon the fusions will end, allowing the gravity to win. The core shrinks down to a fraction of its original size. Once the core contracts, it immediately begins to feed on the rest of the now dead star, the black hole basically eating its way out. Finally, the star explodes. The explosion produces 100 times more energy than our Sun will produce in its lifetime. Now that a new black hole formed, not even light can escape the pull of the black hole's gravity. This concludes the presentation of the life cycle of a star and the formation of a black hole. Thanks for watching.